for medians, what they are in general, it's a line that goes from your vertex to the midpoint of the opposite side. So something that's a little bit different with our, so we have triangle, with our perpendicular bisectors. The rule of a perpendicular bisector is that it has to bisect a side perpendicularly. And then from there, we created this circumcenter, and then there was a line that we can draw from the circumcenter to the vertices. That was for when we had our perpendicular bisector. Same thing with an angle bisector. We were able to draw parts that bisect the angle, and then from that, we drew these right angles, talking about their distances. So what was really happening is you had 6 separate lines. We had the green ones, which were the original, like whatever created the angle bisector or the segment or perpendicular bisector. And then the green line created some sort of relationship. Talks about things being equal and all of that. How the median is different. This segment all the way from A to E is one continuous line. So this one, it is really only 3 lines. And then your centroid is where those 3 lines cross. The relationship that we have here is that for your centroid, the distance from the vertex to the vertex to the centroid is 2/3 the distance of the whole thing. So this is 2/3 of the entire median of A to E. It's specific of going from the vertice. So, since going from the vertice to the centroid is 2/3, that means over here, going from that midpoint of the other side to the centroid is 1/3 of the distance. So because of that fraction, that distance, it can be written as a ratio. So the ratio of like vertex to the centroid, and then the centroid to the midpoint would be 2:1, the ratio of 2:1. So most times it's like 3 different ways I can ask you about it. I can ask you about the relationship between one of the smaller parts to the entire median, whether it's the longer one or the shorter one, or I can ask you about the relationship between the 2 different segments. So it's really like 3 different ways to be asked a problem within one thing. So we're going to just go through this picture. So on this picture, AD is 15, so this whole thing is 15. CG is 13, which is labeled. AD is perpendicular to CB. That is not a requirement of a median ever. That's like a special thing that just happens sometimes. So perpendicular does not matter for a median. It's only sometimes that you would see that. Which, since we have perpendicular, that brings us right angles or right triangles. So potentially the Pythagorean theorem is thrown in there. So going through and solving each of these. Since AD is 15, we need AG. 10. Because what that theorem was just saying is your distance from the vertex to the centroid is 2/3 of the whole thing. So 15 times 2/3 is how you got that. And then looking at C or G, D, this part here, what would that have to be? 5, yeah. You have 2 options. Option 1, we figured out the other one had to be 10. So if the whole thing is 15, so that has to be 5. Or that relationship, the smaller distance, the distance from the centroid to this side, is always going to be a third of it. Going through the rest. CD is here. Thankfully, because of this marking, we have a right triangle. And we know 2 of the sides. We know the side or the leg and the hypotenuse. So Pythagorean theorem to get that missing side.
Wait, how do you know which one's like A, which one's B, which one?
A and B doesn't matter. C is always your hypotenuse. That answers 12. And then since that is a median, that means since this is 12, this side is also 12. Because of a median. Median always goes from the vertex to the midpoint on that other side. Vertex to the midpoint on the other side. Okay. Now to get GE. GE is over here.
Would you do the whole like 2/3 thing?
I mean, kind of.
6 in the amount,
It's 6.5. How did you get that?
where can
The relationship between this and this is always a 2-to-1 relationship because of that 2/3, 1/3. So that shorter segment is always half of that longer one. So 6.5. And then the last one is GB, which is what? 13. Because the only reason for this one is because it's the exact same triangle as our other one. That doesn't happen for all centroids. It's just this one specific because of that right angle. Okay, so let's do a little bit more. On to the next part. So we're finding x for all 3 of these. We're going to change the last one. Just so we'll heads up. On this one, L is the centroid, which means all of these are medians. Medians and centroid have the 2/3 relationship. So it's always the vertice to the centroid that is 2/3. So if we know OL is 8x, so this is 8x. OQ, which is the whole thing, is 9x plus 6. Any ideas?
Did you multiply 9x? Oh, wait. 8x plus 8x equals 9. Wait. Oh, the whole thing.
I like the multiplying the 9x plus 6 by something.
1/2. I mean, yeah, 1/2.
Not 1/2.
2/3. No,
It would be 1/2 if we were talking about this little, like, if we were talking about the relationship between these two, that's our 2-to-1 relationship. What we have marked here, this is 2/3. This part right here is 2/3 of the whole thing. So this 8x is 2/3 of the whole thing.
Oh, are they the
Uh-huh. 4. Okay. So then x is 2. Okay. So watch on number 7, so do the next one. I'm gonna change number 8 to that last one, so don't do it just yet. So I want y'all to do the number 7, the next one. Same 2/3 relationship. So 2/3 of your 3x plus 3 equals x plus 4. Is that right? Yep. So the next is 2. Okay, what I want to change on number 8. Yep. Okay, change this to say RL. Still using the same stuff, but now it's RL. So now you know that this is 10x minus 4, and the whole thing of MR is 12x plus 18. So how is this problem now different? Right, that whole thing, or that shorter distance of your 10x minus 4 is 1/3 of the whole thing, which is that 12x plus 18. Good so far? 5/3 is your answer? Okay. So those are little practices for going from like the whole median and then the two different segments that we have. So whether it's the 2/3 or the 1/3 relationship. Now we're looking at it if it was a graph. So looking at it on a graph, I'm going to label it. It will be A, B, and C. So 110 is A, 9, 1, 2, 3, 4, 5 is B, 2, 3, 4, 5, C. Okay. We need to find the coordinates of the centroid. Things you have to think about. How is a centroid made? What's it made out of? What is that line, that special segment called? What's that? Centroids are made out of median. Okay, medians. Where does a median come from? Or how is a median made? It goes from what to what? Okay, it goes from what parts of the triangle are important? Look back at that very first thing that we had. Okay, midpoint and the vertex. So those are important. We need a vertex, and then we need the midpoint of the side across from that vertex. Once we get that, because really to get the centroid, you only need to find one of the medians. Now you have to use a little bit of strategy, because as long as you find one of the medians and we do that 2/3 relationship, the rest of them would have the same relationship, so you don't have to do it 2 at a time. You just have to do it once. But this is where a little bit of strategy is going to come into play. Which one could potentially be our easiest midpoint, like our easiest distance to have to find? So you're looking for, is there potential for there to be horizontal or vertical lines? Because that way you can just count a distance instead of having to use your distance formula. Anyone have an idea or a guess of where a potential vertical or horizontal line could be? Going from, say that again? Okay, so the vertex of C to the midpoint of AB. So let's just test it. Because midpoint's fast, right? So we're finding the midpoint of AB. That's 1 plus 9 over 2. And then 10 plus 5 over 2. Right? So that would be 5, and that would be 7.5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7.5. Clearly, I drew that not correctly, but that's why we don't trust the picture. Is that distance a vertical line? Yeah, so you can count it. What's the distance there?
Oh,
7.5. Okay. All right. You can work with 7.5. Right? I have a question. What are we gonna have to do with that 7.5? Split it into thirds, right? Okay. What is 7.5 split into thirds? 2.5 for each of them, right? Okay, love that. So 7.5 split into thirds, so that distance, so our median, that distance is 7.5. When we split it into thirds, that's 2.5. But we need what? 2/3 and a third. So one of it would be 2/3 of the distance would be 5. Right? Okay. So that means on here, if I'm using 2/3, that means I'm going from the vertex. And that means I need to go up 5. 1, 2, 3, 4, 5. Ta-da! There's my centroid. What's that order pair? 5, 5. The trick for this, because with first period, I used B to AC, which was also, it was a horizontal line. So the trick with this, most times I'm going to give you one of those medians being either horizontal or vertical. So if you go through what we just did, I did it all in pink, and you end up having like not a horizontal or vertical line, it's easy to find a midpoint pretty quickly. Y'all are pretty fast at that. So if you just do that, try and get the easy problem first. Because if you don't, then instead of doing what we just did here, which was the easy counting, you would have to do the distance formula. And then find all that stuff with your distance formula. Okay. Are we good? Yes. We have one more centroid problem. On this final centroid problem, we have a triangle. R is the centroid, EH is a median. They're all, we need to find ER, or we know that ER, is x plus 20. And we know that RH is 3x minus 2. We need to find the full distance.
So multiply RH by 2 and set it equal.
Wonderful. Remember, this distance is 1 to 2, that relationship. So if we double this small one, it would be equal to the longer one. So 5x equals 24. So 24 fifths, or 4.8. But ask for EH, right? So EH is that full thing. So EH is really 4x plus 18. So 4 times 4.8 plus 18. Which is 37.2 is your final. Okay, so we have now successfully seen all three, like, well, I guess four because the graph, all four ways that you will potentially see problems, maybe a little bit more applied sometimes, but like, those are your basics. We're going to look at the orthocenter next. Orthocenters are made out of altitudes, and that's basically it. That's all we get. So with our orthocenter being made out of altitude, what's going to be tricky, so I'm actually going to go to the next page just for a minute. If you remember an altitude, altitudes are the height of a triangle. They go from the vertex to the opposite side, but they have to be a perpendicular segment. So depending on the triangle itself, altitudes are in the triangle, on the triangle, or outside of it. Do y'all remember? So like this one on the right, what's in black is the actual triangle. But when you're talking about the height of a triangle, which is your altitude, it's going from each vertice to a perpendicular line. So what I just did in pink is your altitude, but you would have to extend that triangle as well. So that's where pictures are going to look a little bit confusing sometimes, or like having to draw it yourself can be confusing sometimes. Just remembering that altitude, like no part of that altitude is in the triangle. The vertex is on the triangle, but like the altitude itself, the line is outside the triangle. So it's going to be dependent on the type of triangle. And then when it comes to orthocenters, like that's it. Or not orthocenter. Yeah, orthocenter. When it comes to orthocenters, that's it. The only thing we have, like there is no segment relationship, there is no like equal, there's no 2/3 about anything. The only rule about our orthocenters is that it's made up of our three altitudes. That's it. Which means for this section, since we're creating perpendicular lines, it's just going to be a bunch of staggering theorems. But, I mean, that's all. And maybe like vocab and stuff like that. Because, let's go here. Depending on our different triangles. So finding the different orthocenters, you're to create a altitude. It has to go from the vertex to that other side, creating a perpendicular angle. It has to go from the vertex to the opposite side, perpendicular angle, or triangle, and then perpendicular. It doesn't have to bisect the side. It doesn't have to bisect an angle. The only rule is it goes from the vertex to the side with a perpendicular line, forming a perpendicular line. So if you have an acute triangle, it is going to be inside, your orthocenter will be inside the triangle. If you have a right triangle, each of your legs are heights of a right triangle, and then your third one would be here, which means your orthocenter is always going to be that vertex where the right angle is located. So it's always going to be on the triangle. And then for the obtuse angle, so I added in those dotted lines because those are extensions. Those are some auxiliary lines. Here's one altitude. The next altitude. You can't just go straight down that next altitude. It is outside. It creates that that perpendicular line. And then the same thing's happening with that other vertex. There we go. Perpendicular line. And so if you see what happens here, my straight lines are not very good, but you'll get the idea. Your your orthocenter is outside of the triangle. So what's going to be tricky is that like the pictures look kind of weird sometimes. Most times what you'll see is like a dashed line of some sort representing those auxiliary lines, maybe different colors like in your book for questions like that. Usually your book uses like red and blue to be extra lines, and like normally the thing itself is black, I think. I'll have to look back, but just paying attention to that, that's where it gets tricky. Okay, so let's have a little practice about combining some stuff. On number 9, so we take our triangles, we have BD, it's asymmetric segment BD. Is it a median? Is it an altitude? Is it a perpendicular bisector? So yes, no to all of those. If we look at this first one, is it a median?
Yeah.
What are the only rules for median?
It goes from where the vertex is to
Yep.
the median.
Yep. Goes from the vertice to the midpoint. Yep. But yeah. Vertice to the midpoint. That's the only rule. It doesn't matter about right angles. So the only markings you ever need for something to be called a median is that the line goes through the vertex and you see that congruency symbol. So yes, this is a median.
When it goes to the vertex, it doesn't have to be bisected.
No, it does not have to bisect the vertex. It will only do that sometimes. It'll only happen for special conditions. Okay, altitude. Rules about altitude. Vertex to the opposite side forming a right angle. It doesn't have to bisect anything. Just goes from the vertex to the opposite side forming a right angle. So, is that an altitude? Yes. Okay, last part. Perpendicular bisector. Rules about perpendicular bisector. Perpendicular bisectors don't have to go through the vertex. The only rule about a perpendicular bisector is it has to be a perpendicular line bisecting a side. Do we have a perpendicular line bisecting a side? Wonderful. So that means this is a perpendicular bisector. So the only thing truly for a perpendicular bisector, if I even just cut it, if I didn't even like show the full thing, if it just went to what I have as blue, like if that was the only thing on your paper, perpendicular and bisecting, that's all you need. It doesn't have to go through a vertex. Okay. Next one is the median. Goes from the vertex and bisecting the other side. That makes median. No. Altitude. Altitudes go from the vertex, creating a perpendicular line on the other side. No. Is a perpendicular bisector? Nothing. Okay. How much y'all solve this one? Y'all do that. Okay. So that was your setup. You got extra time. Okay. Last time for class is the graph of an orthocenter. So -2, 4 is A, 4, 4 is B, and then 1, -2 is C. Okay. With an orthocenter, there has been no relationship about things being congruent, like sides. There's been no relationship about anything with distances. The only thing that happens with an orthocenter is that it's made up of altitudes. So the only way to find that orthocenter is find where two altitudes intersect.
You only have to do two of them, you don't have to.
No, you only have to do two because two lines intersect in exactly one spot. So wherever those two intersect, the third one has to. So we're finding where our two altitudes intersect. So what is important about an altitude?
It intersects at the midpoint.
Not the midpoint.
The
What kind of, it's a special, it uses the vertex. That's one part. And then from the vertex, what's the relationship to that other side? It's not intersecting it. And it just has to be perpendicular to the other side. So we're going to be creating two different equations for lines. And then find where those two lines intersect. So potentially solving a system here. What is helpful is that if we have horizontal and vertical lines, that is our other, like, those will always help you for this part. So looking at the picture, looking at the graph itself, any ideas of where we would have a horizontal or vertical line for an altitude?
C.
From C. You know that because the side that's across from C is horizontal. If it's horizontal, then the opposite of it has to be vertical. So that means there's your altitude. So the altitude from C, that equation is x equals 1. Which means wonderful news for you, because you already know the x coordinate of our orthocenter is going to be 1. If x equals 1, it's got to be on that line. So it's got to be 1. Now for the other one. We need to find two of the altitudes. We got one, we need the other one. So to get the other one, pick one. Huh?
B.
From where?
B.
Okay, so altitude from B. That means we need it to be perpendicular to AC. So what's the slope of AC? Don't trust my drawing. 1, 2, 3, 4, 5, 6.
2.
1, 2, 3. So -2. Which means the slope of our altitude has to be perpendicular to it, so a +1/2.
Wait, the measure of AC is negative.
Slope, M. Oh, sorry. Okay, so now this is where we have potentially an easy problem, potentially a hard problem. Easy option, you know it has to go through B, and if your slope is 1/2, does it make a nice y-intercept? So down 1/2, down 1/2, oh wow, it sure did. So the equation of that line, 1/2 x plus 2. If it didn't work out that nicely, maybe try the other altitude. Maybe that would be better. If neither of them work out that nicely, then use type slope form. Okay. Now what?
Find the intercept.
Yeah, find where they intersect, because we need this point. Well, we already know x is 1. Put a 1 there. Two 2.5. And we're done. things to keep in mind when it comes to graphing. Usually you'll have some sort of horizontal or vertical line. Look for it. If you don't, then of course you have a little bit harder work. But there's a lot that has to like go on in your head to remember the difference between all the different ones. So most times on a test or quiz, I'm giving you a horizontal or vertical line. Now, if you don't find it, then it's solvable. But most times, like a clue for you guys, I'm most times going to give you that little bit of extra just to help you, because I know it's a lot. Okay.